If 1 over 2k plus 1 over 2k is 1 over 2x, then x, expressed in terms of k, is which of the following? Well, conventional wisdom says that you can try problems like this by plugging in numbers to see which of the answers yields an equivalent solution. And I'm going to give that a try, right, according to the conventional wisdom, which says you don't use 0 or 1, but maybe you can use 2, right? Maybe 2 is safe. What I mean by that is we're going to use k equals 2, see what x is, and then compare that to some of the answers back in terms of k. If we go that route, then what we're going to be doing is 1 over 2 to the second power plus 1 over 2 to the second power equals 1 over 2 to the x power. Now, this is nothing more than 1/4 plus 1/4, being equal to 1 over 2 to the x power. But 1/4 plus 1/4, you'll recall from your fractional arithmetic, since the denominators are the same, we will add the top numbers and keep the bottom number the same. This becomes 2/4. 2/4 is equal to 1 over 2 to the x. But you'll recall from reducing fractions that 2/4 is actually 1/2. So 1/2 is equal to 1 over 2 to the x. So that implies that if 1 over 2 is equal to 1 over 2 to the x, then that's like, well, what power of x here gets you 2, effectively 2 to the first power? Well, obviously the answer is that x equals 1. Okay, that much must be true. Now, remember, x is equal to 1, so we have to check each of these answers back in terms of k, noting that k was 2. You're starting to see why I'm not really a fan of this plugging in method in every case. Well, option A suggests that k over 2, read 2 over 2, right, is equal to 1, so it is equal to x, so that must be the answer, right? Seems legit. All right, good video, guys. See you next time. Just kidding, that's actually not the answer, of course, because option B says the same thing. If k is equal to 2, then 2 minus 1 is equal to 1, which is supposedly the thing that x is equal to, right? So either of these could actually be correct. Our answer is not conclusive. And in situations like this, if you're going to double down on the plugging in method, then you're going to need to try something else, okay? Hopefully another number will yield an answer that's less ambiguous. Let's try k equals 3. All right, so if k equals 3, let's get rid of this stuff now. If k equals 3, we're going to have 1 over 2 cubed plus 1 over 2 cubed is equal to 1 over 2x. Now 2 cubed is 2 times 2 times 2, which is 8. So we have here 1/8 plus 1/8 equals 1 over 2 to the x. 1/8 plus 1/8 will be 2/8, but that will be 1/4. And that will be equal to 1 over 2x. Now this question is like asking what power of 2 is actually equal to 4, okay? All other things being the same. Of course, 2 squared is 4, therefore x must be equal to 2 in this case. All right, now let's try and go back and figure it out. Remember, we said k was going to be equal to 3. So now 3 over 2 is not equal to 4, so we've eliminated this answer now. It was true when k was 2, but not when k was 3. This one is true now, okay, because k was equal to 3, we get x equal to 2. And obviously, these aren't going to work. This is 4, 3 plus 1, this is 6, this is 9. Okay, they weren't true for the k equals 2 option either, but I forgot to check them. So we've got our answer on 2 attempts, right? Conventional wisdom does suggest that 2 is a good number to plug in because it's easy to work with, but unfortunately that would be very misleading because you'd probably stop here if that was your only option, right? Well, the elegant way of doing this, and you know I'm always going to throw it out there, is just to try and work with the laws of exponents a little bit more succinctly, okay? We have this statement 1 over 2k plus 1 over 2 to the k is equal to 1 over 2 to the x, and I'm going to work this problem symbolically now. What you notice about this situation is that it's kind of like adding fractions, okay? The reality is that these are two fractions with the same denominators. Therefore, we can add them together, adding the tops, keeping the bottom the same. We have here 2 over 2 to the k power. So this is equal to 1 over 2 to the x power. Now, this can be simplified. This is 2 to the first power, and what we're doing here is dividing exponential terms, and I'll write the rule that does apply, which is that when dividing exponential terms, what I'll not write here is that they do have to be the same base, okay? This is 2 and this is 2. When dividing exponential terms, we subtract. Subtract exponents. That means that we have 2 to the 1 divided by 2 to the k, which is 2 to the 1 minus k. And this is equal to 1 over 2 to the x. But how does that help us? Well, because this is actually what you get from doing 2 to the negative x power, right? So this is going to be 2 to the negative x power, because negative x power would reciprocate this and put it under 1. So what I'm interested in is that relationship there. 2 to the 1 minus k is equal to 2 to the negative x. And if this is true, if these bases are the same, then these exponents must be the same. 1 minus k is equal to negative x, and you can turn this around so that it says k minus 1 is equal to x. So there's no ambiguity at all. Once again, the answer is B.